Hi guys, welcome to my video, and in this video I'm going to talk about work, energy and power. The first thing that I'm going to talk about is work done. Basically, work done is when you have an object and it moves a certain distance when it's applied by a force. We call it work done. The equation for work done is W equals to F times the change in distance or the change in displacement. One important thing is the force must be parallel to the direction of the motion. So now what if your force is not parallel to the direction of the motion? So which means it will be like this, where the force has an angle with the horizontal. Since we know that the force must be parallel to the direction of the motion, right? So we can resolve this force into the horizontal component. So which means it's F cos theta. So the formula for it will be work done equals to F cos theta multiplied by the change in displacement or distance. Another important thing is, if let's say I have a force that is perpendicular to the direction of the motion, we say there's no work done in it, because as I said just now, the force must be parallel to the direction of the motion. So if it's perpendicular, the formula is not valid anymore. Okay, so if you're wondering where can we see this kind of situation where there's no work done but the object is moving, is when a waiter or waitress is holding a tray. Okay, so the only force exerted on the tray is the contact force, which is going upwards, and the tray is moving forward. So you can clearly see that the contact force is actually perpendicular to the direction of the motion. So this is where we say there's no work done of the waiter or the waitress on this tray. The second thing is about kinetic and gravitational potential energy. These two energy is the typical energy that you meet in any mechanics question. We call both of these energy as mechanical energy. And these two energies is always related to each other, so you'll see both of them in a question quite often. Where kinetic energy comes from? The kinetic energy is actually comes from the kinematic equation, which is v squared equals to u squared plus 2a change in displacement. In here you also can use another symbol called s, which is v squared equals to u squared plus 2as. It depends on you. And another equation that is in use to derive kinetic energy equation is F equals to ma, which is from the Newton's second law. If we arrange this equation, we will get a equals to v squared minus u squared divided by 2s. By substitute the a into the F equals to ma, we get F equals to m times v squared minus u squared over 2s. Okay, so by multiplying both sides by s, we get Fs is equal to half mv squared minus half mu squared. Okay, so we know Fs is actually work done. U is the initial velocity, so half mu squared is the initial kinetic energy. So V is the final velocity, so half mv squared is the final kinetic energy. So work done is actually equals to the final kinetic energy minus the initial kinetic energy. Kinetic energy is actually an energy if a mass or an object is moving with a velocity. For potential energy, in a simpler way to explain it is when an object has a height from the origin. For example, if we take the floor as the origin and we have a ball which is 2 meters, we say the ball will have potential energy because it has a height from the origin. So first, if you want to find the work done of this ball with the height of 2 meters, we can use W equals to F times S, and the only force that exerted on the ball is the gravity, which is the weight. So F is equals to mg times S, and in here the displacement is actually the height of the ball from the origin, so we can take it as h. So the potential energy, or we call it as gravitational potential energy, will be equals to mgh. It's really important that you state it's a gravitational potential energy, because potential energy can exist in many forms. For example, potential energy in the molecules, or the potential energy in electricity. Okay, so it's really important to state that your potential energy is actually gravitational potential energy. Okay, so the next thing that I'm going to talk about is the conservation of mechanical energy and work energy principle. Okay, so conservation of energy states that no matter where the object is, the total energy will always be the same. For example, if I have a slope here and there's a ball rolling down the slope. Okay, so here we take the total energy, which is GPE plus KE, will be 1000 joule. In here we take the slope as a smooth slope, so there is no friction on it, so there is no work done in friction. Okay, so no matter where the ball is, let's say here or here or here or maybe here, the total energy will always equals to 1000 joule. Yeah, so this is conservation of energy. So the last thing in this chapter is power. Okay, what is power? The power is the rate of change of energy, or the rate of change in work done, which is the same. So this is the definition for power. And since we know that work done is equals to force times the change in distance or displacement, right? So P will equals to force times the change in displacement divided by the change in time. Okay, in here we can clearly see that it is equals to velocity, because velocity is actually the change in displacement divided by the change in time. So P will also be equals to force times velocity. So that's all for this video, and I will bring up some questions in the next video, which is about work, energy and power. So the question in work, energy and power is actually quite simple, and I think it's actually one of the easiest topic in the further mechanics. So I hope you guys enjoy this video, and if you like this video, please leave a thumbs up and subscribe to my channel, and I'll see you again.